Welcome everyone. The question that is shown on the screen is a question number 14 of the CBSE sample paper 2025. It is an assertion reason based question. The first statement is given, which is as an assertion: in a hydrogen atom there is only one electron. Okay, but its emission spectrum shows many lines. Second statement, which is the reason, are in a given sample of hydrogen, there are many atoms, each containing one electron. Hence, many electrons in different atoms may be different orbits. So, many transitions from the higher to lower orbits are possible. Okay. So, let us discuss this, and obviously, here also the four options are given. You can see it. So obviously, if you take for an experiment, if you take 1 gram hydrogen atom, if you are able to take 1 gram hydrogen atom, then this 1 gram hydrogen atom contains 6.023 into 10 to the power 23 hydrogen atoms. Just think how much is the number. Okay. A minimum amount you have to take 0.25 gram, 0.1 gram. If you are able to take 0.1 gram, okay, or 1 milligram, then the number of atoms contained in the sample is huge in number. Huge in number. Okay. We also know that in addition to that, the hydrogen is one nucleus at the center and one electron is revolving around the nucleus in a circular orbit, and that is at n equal to 1. But no one has said that if the energy is given to that particular electron from outside, then what will happen? Actually, our Bohr's law says that if an electron in a particular energy level, that is EI, if some energy falls on it, then what will happen? It transits from the initial level to final level. Okay. Obviously, its energy has increased, and it just transits from the initial level to final level. And now, what will happen? If you want to see the emission spectrum, then obviously you have to energize that sample. And different electrons from different atoms. Why I am saying? Because as much minimum amount of hydrogen you will take that contains lots of number of atoms. And if each atom, obviously it is quite evident that all atoms are not taking the same amount of energy or absorbing the same amount of energy. It may take different energy. Then what will happen? Obviously, according to Bohr's law, if this level is talking about n equal to 1 level, this level is talking about n equal to 2 level, this level is talking about n equal to 3 level, this level is talking about n equal to 4 level, and n equal to 5, okay, and so on. And after that, obviously continuum is formed. Obviously the energy levels are so close to each other, you cannot distinguish them. It has a energy level rather than a band. N equal to 1, basically you know that it is minus 13.6 electron volt. Okay, that is minus 5.4 electron volt. It is minus 1.4 electron volt. Similarly, different energy levels have different energy gaps. If the atom who is in the n equal to 1 is getting the 13.6, it will just comes out from the atom. Okay, comes out from all the bindings of the atom. Okay, so if by absorbing different energies, okay, of different atoms, let us say one atom transits from n equal to 1 to n equal to 2, another atom transits from n equal to 1 to n equal to 3, another atom transits from n equal to 3 to n equal to 4, one atom transits from n equal to 2 to n equal to 3. So okay, so we all kind of permutations and combinations will going to happen here. Okay, That's why it is said, it is a very simple statement. It is said, in a given sample of hydrogen, sample as much small as we can take, it contains lots of atoms. Many atoms each containing one electron, hence many electrons in different atoms may be different orbits, so many transitions from higher to lower orbits are possible. Because after energizing it, different electrons of the different atoms at different energy levels, and when they are transits from the higher energy level, just like from n equal to 4, one is transits to n equal to 1. Okay, n equal to 2, 1 transits to n equal to 1. So depending on Lyman, Balmer, Fund, Humphreys, and all of these things, different lines, different spectral lines we are getting. Okay, so where is the breakthrough? Where this idea is breakthrough, basically when you are taught, it is so that one hydrogen atom, one electron, one transition, but when you are going to do that practically in lab, it is not possible to take one atom. We are taking a sample, as much minimum as you can take, that contains lots of atoms. So all of the atoms gaining different amount of energy according to all kind of permutation and combinations, and after it is transits from the higher to lower and emits and shows different spectrum. Lyman, Balmer, Fund, Humphreys, and obviously from infrared to far infrared and visible, all of these things we can see here. Okay, so here option A is the correct answer, because here the assertion what is given, the reason, the second statement explains that assertion is a very good way, and it is basically we can say transitions from the theoretical to practical. Theoretically, we are thinking one electron, one atom, but not, it is not possible. You have to take a sample, as much minimum as you can take, it contains lots of atoms. So all the possible kinds of transitions, it is visible to you. Okay, thank you all of you.